everyone, this is Ankit. I'm back with another video on affine transformation. In this video, we are going to talk about horizontal stretches, vertical stretches, and what do we mean by enlargements. So let's quickly jump into it. Let's say in a plane, I have been given a point which looks like this. This point over here is 1, 1. And I want to push this point 5 times as the original distance from the y-axis. Originally, this plane is at a distance of 1 units from the y-axis. I want to push it to the 5 times. That is, I want to push it to here, which becomes 5, 1. And this way of transforming a vector that is 1, 1 into a point, into an image point that is 5 times from the y-axis is what we called as a horizontal stretch. So basically what I have done is that whenever I want to push a vector 5 times away from the y-axis, the scale factor in my example over here is known as E, which I took as 5. So whenever I want to push a vector away from the y-axis, this is called as horizontal stretch, and the transformation matrix for that looks like this, which is k times 0, 0 and 1. So that's my transformation matrix for a horizontal stretch. And similarly, what do we mean by vertical stretch is if I have been given a point, the same point, let's say 1, 1, which is at a distance of 1 unit from the x-axis, and I want to push it, let's say 4 times away from the x-axis. So I will come at a point here which is 4, 1. So over here in my example, the scale factor, which is k, is 4. So what does the transformation matrix A looks like in the case of a vertical stretch? That is 0, sorry, that's 1, 0, 0 and k. So this is my transformation matrix in case of a vertical stretch. And this is my transformation matrix in case of a horizontal stretch. So I hope we are clear with what is a vertical stretch and what is a horizontal stretch. Let's talk about enlargement that combines the features of both vertical stretch as well as horizontal stretch. So let's say in a plane, if I was given the same point, which is 1, 1, and I want to push this vector away from the origin, let's say to a point which is 4, 4. I want to push this vector 4 times away from the origin. So what I have done is that I have pushed the vector 4 times away from the origin. So in this example, my scale factor, which is always k, is 4. And how does my transformation matrix A looks like? It looks like k times, I'm sorry, not times, it is k, 0, 0 and k. So that's my transformation matrix in case of enlargement. So the essence is that a horizontal stretch moves the vector away from the y-axis. A vertical stretch moves the vector away from the x-axis. But on the other hand, enlargement moves the vector away from the origin. And similarly, as compared to enlargement, we have something known as reduction. Just like in enlargement, when we were trying to push the vector away from the origin, in reduction, we try to bring the vector towards the origin. So reductions are the cases when the value of k lies between 0 and 1. So let's say if I have been given a plane and the same point, that is 1, 1, which is here. And if I try to reduce my vector, and let's say the scale factor is equals to half, so what does my transformation matrix looks like? It looks like half, 0, 0 and half. What was my object point over here was 1 and 1. So let's try to find out my image point. That is, after doing a reduction, how does the image point looks like? So x dash will be a times x, which in this case will be half 0 0 half times 1 1. So after doing it, I will be arriving at a point half and half, which is somewhere around here. So yeah, that's how the reduction works. So I hope you are clear with what is a horizontal stretch, what is a vertical stretch, what is a enlargement, and what is a reduction. So that's all for this video. I'll see you in the next one. Thank you so much, everyone.